Heat lightning is the name used for the faint flashes of lightning on the horizon or other clouds from distant thunderstorms that do not have accompanying sounds of thunder. This happens because the lightning occurs very far away and the sound dissipates before it reaches the observer. The term is a little misleading because it has nothing to do with the heat of the lightning itself. At night, it is possible to see the flashes of lightning from very far distances, up to 100 miles, but the sound doesn't carry that far. Lightning results from the discharge of negative ions created from the friction of ice and water particles bumping into each other at the bottom of a cloud. Heat lightning can be an early warning sign that thunderstorms are approaching. In Florida, heat lightning is often seen out over the water at night, the remnants of storms that formed during the day along a sea breeze front coming in from the opposite coast. Heat lightning is not to be confused with electrically induced luminosity actually generated at mesospheric altitudes above thunderstorm systems, a phenomenon known as sprites. Atmosphere. The movement of sound in the atmosphere depends on the properties of the air, such as temperature and density. Because temperature and density change with height, the sound of thunder is refracted through the troposphere. This refraction results in spaces through which the thunder does not propagate. The sound of thunder often reflects off the Earth's surface. The rumbling sound is partly due to these reflections. This reflection and refraction leaves voids where thunder cannot be heard. Curvature. The Earth's curvature also contributes to distant observers not hearing the thunderclap. Thunder is more likely to be bounced off the Earth's surface before it reaches an observer far from the strike, and only the right refraction and reflection of the sound off of the atmosphere will give it range it needs to be heard far away. The reflection and refraction in the troposphere determines who hears the strike and who doesn't. More often than not, the troposphere will reflect the light, and leave out the sound. In these cases some fraction of the light emanating from distant thunderstorms is scattered by the upper atmosphere and thus visible to remote observers. Under optimum conditions, the most intense thunderstorms can be seen at up to 100 miles over flat terrain or water when the clouds are illuminated by large lightning discharges. However, an upper limit of 30–50 miles is more common due to topography, trees on the horizon, low to mid-level clouds, and the fact that local visibilities are generally no more than 25 miles. Variability of anvil height also contributes. 45,000 feet is very common in the mid-latitudes for warm season thunderstorms, but the anvil height can range from 35,000 feet to a current record of 78,000 feet. Silent lightning. Silent lightning also occurs where airborne matter muffles the thunder, such as heavy snow in winter storms and dust and sandstorms. In some instances, heavy falling snow has silenced thunder from cloud to ground. Lightning strikes as close as 1 to 2 miles from the observer, and severe dust storms are even more effective in many cases. See also, dry lightning, references, notes. External links, http, www.islandnet.com Weather Heat Lightning GHTM, http, or files or Gaplet Index HTML, http, www.weatherprediction.com 274/ http, www.buzzlecomb Heat Lightning Facts HTML